This is lesson 102. It's sums and products of functions. But before we get into the lesson, let's remind ourselves, what does function notation look like? Remember, this is f of x, something to this nature, equals 2x plus 3. And this says, when I plug in a value for x, my solution is the y value. So f of x is interchangeable with the y value. So if I literally was graphing this on the Cartesian coordinate system, this would be my x-axis, and this would be my f of x axis. So it becomes my f of x as opposed to y, all right? Now, if I were to say, what is f of 2? That says plug in 2 into the function. And what is my output? So 2 is my domain. Remember, the domain is all your x values. Your f of x value is your range. All right, so I plug in 2 for x. And we end up with, that's 4 plus 3, which is 7. So if I were writing it as a coordinate pair, it would be 2, 7. The x value is 2. The f of x, or the y value, is 7. So now we're going to have two functions with domains for each function. Domains means permissible x values. And then we will have, we're going to add them and subtract, and we're going to multiply. All right, so looking at 102. 102.1 on top, page 423. We have h of x equals x plus 3, and its domain is all reals. So anything I can plug in every real value for x, I will get a real value for y. And that is a Greek symbol phi of x equals x squared minus 6. Its domain is just integers. And it wants us to find h plus phi of 2. All right? This is the same thing as if I plugged in 2 to h and added to it 2 plugged into the other equation, other function, okay? It's the same exact thing. So these can be written interchangeably. All right, so this is how I'm going to solve it. If this were just x, well, let's not do that right now. Okay, so I'm going to plug in 2 into h of x, and that's 2 plus 3. That's what h of 2 is. Then I'll plug it 2 into phi. Remembering that when I plug in a value for x and square it, if it's a negative, it's always going to be a positive. All right, so that's 2 squared minus 6. So h of 2 is 5. And phi of 2, that's 4 minus 6, which is negative 2. So that equals 3. That is our solution. Does it fit in the domain? Here's what we needed to ask ourselves actually before. Does 2 fit in the domain of both of these functions? 2 is a real number, and 2 is an integer. So therefore we can solve for it. That is not typical of other textbooks. I do believe what we're asking here is, do we understand domain and range, right? And do we understand the set of numbers? So if this would have asked, what is h plus phi of 1/2? 1/2 is not an integer. So therefore there will be no solution, because 1/2 is not in the domain of this function. So there would be no solution. Okay, so you have to make sure that what you're plugging in for the value of x is in fact in both of the domains, in the domains of both of the functions. All right, look at example 2. We have given h of x is x plus 3. Its domain is all reals. And we have g of x equals 2x squared plus 5. Its domain is only negative integers. All right? Then it wants us to find what's h plus g of 5. Well, is 5 in the domain of h of x? Yes, it is. Is 5 in the domain of g of x? It is not, because it's a negative integer. So there would be no solution. But I'm going to work this one because we need practice. I'm going to say the domain is all reals. Okay? With the domain of g of x being negative integers, there would be no solution. All right? But we're going to change it. So this is really the same thing as h of 5 plus g of 5. So we plug in 5 into h of x, and it's 5 plus 3. Then we plug in 5 to g of x. So it's 2 times 5 squared plus 5. Why do I put this second function in parentheses? Because if this was a negative, then that negative would be distributed to both terms. When we're adding functions, these terms, the sign doesn't change. But if we were subtracting, that negative would be distributed to both of the terms for that function. All right, so 5 plus 3 is 8. 5 squared is 25. 2 times 25 rather, is 50 plus 5. So 50, 5, and 8 is 63. I had to work real quick in my brain. 63. So if this domain for g of x had been changed, that is in fact what the solution would have been. Now, that's sum of functions. Product of functions is multiplication. All right, product is multiplication, right? So now I'm going to have functions that I'm going to be multiplying. All right, so it could look like h times g of x. That's the same thing as if I take h of x and I multiply it by g of x. That is interchangeable, all right? And again, we have to look at the domain. Remember, the domain is the permissible x values. X is always your domain. Y is always your range. So looking on page 424 at 102.3, we want to find hg of negative 4. So we want to multiply h times g and then plug in negative 4. Well, we could do it then independently, solve for negative 4, and then multiply them. And that is what I will do. So h of x is x plus 3. Its domain is all real, so negative 4 is an all real. And then g of x is x squared minus 6. Its domain is negative integers. Negative 4 is a negative integer, so that works. So I'm going to plug in negative 4 to the h function, and then I'm going to multiply them. So that's 4 plus 3. This is my h. This is my h. That's negative 4 of negative 4. This will be my g of negative 4. it's negative 4 squared minus 6. So hg of negative 4 equals negative 4 plus 3 is negative 1. Negative 4 squared is 16. 16 minus 6 is 10. So hg of negative 4 is equal to negative 10. All right, let's do the last example. It's example 4, and we still have a negative number. It's f times g of negative 4, where f of x equals x plus 3. Its domain is all reals. Negative 4 is a real number. And g of x equals x minus 5. But negative 4 does not fit in the domain of g of x because it's only positive integers. So the solution would be an empty set. This is an empty set. I've shown you guys this before, but we're going to work this one anyway. We're going to assume that the domain is reals for both of them. Why? Because these are linear functions. The domain truly would be all reals. All right, so we're actually going to work this. All right, so f times g, when I plug in negative 4 for x, is going to be negative 4 plus 3 times negative 4 minus 5. So f times g of negative 4 is negative 1. Negative 4 minus 5 is negative 9. When I multiply two negatives, I get a positive. So f times g of negative 4 is 9. Okay, work your 3 practice problems.